First thing in the morning, turn off your alarm. Maybe check mail or Facebook and Twitter. iPhones and iPods are part of our daily lives, but have you ever thought of what they're made of and how they work? On June 29, 2007, the first iPhone came out. With camera, mail, internet, maps, and so much more, this was a revolutionary device for technology. 5 years and 5 generations later, the iPhone 4S has evolved into a popular cell phone owned by more than a tenth of US cell phone owners.
Apple's iPhone is the pinnacle of modern electronic technology. Quick, useful, and so easy to use that a child can figure out how to unlock it. While carrying this phone around all day long, it's easy to forget just how complex this device is. All this technology that allows us to enjoy Angry Birds, look up game scores, would be impossible without our modern knowledge of physics. Let's start with everyone's favorite, Wi-Fi. Everyone with an iPod knows the simple joy of finding an unprotected hotspot when they want to send a quick email or text message. Wi-Fi stands for Wireless Fidelity, and signals are composed of radio waves. Radio waves are technically electromagnetic waves. Compared to other waves, radio waves have a very long wavelength. They are not very easily affected by the air they travel through. Because they can travel through a vacuum, they are also what is used in phone calls to bounce a signal off a satellite. Before they can do that, however, the microphone must first change the sound energy of the speaker's voice into this electromagnetic wave. It's modulated, or encoded, using either amplitude modulation or frequency modulation. This is what gives us AM and FM radio. Finally, the wave is converted back into sound energy. All of this occurs with little delay. But I'm sure the part of the seemingly magical iPhone that people find the most fascinating isn't the wireless, but the responsive touchscreen. The iPhone uses a technology known as capacitive touch sensing, which uses a grid of power and sensing lines to detect when a current is flowing through them. In a nutshell, when you touch your iPhone, your finger acts as a conductor to complete a circuit. The beauty of this system is that it can be used to detect multiple touches. For a touch to be registered by the processor, software first has to filter out extra grid squares and gather the coordinates of the touch. If the touch starts in one location and ends in another, the electrons flowing through the grid tell the processor to regard it as a swipe. So you can slash fruit to your heart's content. This all adds up to a bright screen that won't work through more insulating materials such as gloves or fingernails. And what would an iPhone be if there were no racing games? The iPhone has a device known as an accelerometer. An accelerometer is a term given to any device that measures acceleration by factoring in movement and gravity. They function much like a pedometer, in that they are able to convert physical stress into electronic signals. The accelerometer in the iPhone is basically just a miniature Wii controller. It detects speed and tilt to find the location of the phone. Because it can tell which way the phone is facing, you can enjoy Facebook in both portrait and landscape mode. Picture this. You're lost in a forest with only your iPhone. But wait, your phone has a compass. The iPhone compass is powered not by a magnet, but by gyroscopic technology. A gyroscope is like a spinning top. It is surrounded by supports known as gimbals, which allow it to move freely. The cool thing about rotational physics is that when you get a disc-like object up to high enough speeds, it will hardly tilt at all. This gives vehicles like nuclear submarines and commercial airplanes a very accurate compass at all altitudes. The iPhone actually uses a very unique form of gyroscope that consists of electrons undergoing the Coriolis effect. The Coriolis effect has to do with movement in a rotating frame. For example, when the Earth spins, it causes water and wind currents to spin. Here in the northern hemisphere, the Coriolis effect makes water go down the drain clockwise as well as let you use your iPhone to find north. And then come the pictures. Florid flowers and plump fruit come to life due to geometrical optics, a branch of physics. A camera focuses images through a series of lenses. Light is scattered outward by the concave or divergent lens, only to be brought together by the convex or convergent lens. The result is a perfectly focused image. Well, it's actually upside down, but the iPhone processor corrects for that, just like the human brain corrects for the human eye. Another really cool physics-based element of the camera is exposure level. By changing the size of the aperture, or the hole in the camera, different amounts of light can enter the lens. The iPhone camera has an option that takes advantage of this called HDR, or High Dynamic Range Imaging. It takes 3 photos with different exposures and then combines them for a smoother picture with less harsh light. We're almost to the end of the physics section, but what would a physics section be without Isaac Newton? The famous physicist came up with 3 universal laws of motion, which we will explain using the iPhone as an example. Say you drop your iPhone from the 27th story of a building. According to Newton's first law, the iPhone will continue to fall until it is acted upon by an outside force. And what would this force be? The second law states that the force is equal to mass times acceleration. So with the typical iPhone mass of 140 grams and gravity's acceleration of 9.8 meters per second, the iPhone will have a force of 1.37 newtons pulling it downward, assuming we ignore air resistance. Air resistance brings us to Newton's third law, which states that every action has an equal and opposite reaction. As the iPhone falls, it pushes down on the air, which in turn pushes up on the iPhone with an equal force and acts to slow it down. This law is perhaps more important in the phone's landing, as it means that the ground hits the phone with as much force as the phone hits the ground. This is why it is always a good idea to have an OtterBox to absorb the impact, or just not drop your phone from the 27th story in the first place. These examples are only a small selection of the many ways physics controls our ability to stay connected to friends using the iPhone. Our everyday lives are made easier by our modern knowledge of physics, which is crucial to the technology that is getting more advanced all the time. What will the iPhone of tomorrow look like 10 years from now? I'll leave you with that question.
The iPhone is powered by a lithium-ion battery. While there are many forms of this battery, lithium-ion batteries are common in today's portable devices. This is a lithium-ion battery pack. A is a temperature sensor, with the purpose to monitor the overall battery temperature. B is the actual lithium-ion cell, and C is a voltage regulator circuit, which is designed to maintain a constant voltage level. D is a notebook connector. This unit connects the lithium-ion battery to the charging unit. E is a voltage tap, which measures the energy capacity of each cell, and F is the unit that checks the state of the battery. The lithium-ion cells can be either cylindrical batteries that look like AA batteries, or they can be square or rectangular. The inside of the lithium-ion battery consists of sheets. The sheets in the battery are soaked in an organic solvent that acts as an electrolyte. Ether is a common solvent. The anode sheet is made of lithium cobalt oxide. The cathode sheet is made of carbon. There is a sheet separating the anode from the cathode. When the battery charges, ions of the lithium move through the electrolyte from the anode to the cathode and attach to the carbon. During discharge, the lithium ions move back to the lithium cobalt oxide from the carbon. While there are many different types of batteries, the basic concept by which they function remains the same. For many years, nickel-cadmium were the only rechargeable batteries suitable for use in the portable equipment like iPhones. In the 1990s, nickel metal hydride and lithium-ion batteries were invented, providing a better energy-to-weight ratio and slower loss of charge. Today, lithium-ion batteries are the fastest-growing and most promising technology for portable devices. While the iPhone is a beloved device for many, there are many negative environmental effects that some bring to light. For example, the waste. After releasing the iPhone 3G, Apple sold more than 1 million devices in 3 days. For the many people whose first phone it was not, hundreds of phones were thrown away. Phones consisting of elements and minerals like lead, mercury, nickel, cadmium, and chlorine. With such hazardous materials headed to the landfill in millions each year, the environmental risk is obvious. Another environmental concern is pollution. In 2010, 34 Chinese environmental organizations brought to light the massive amounts of pollution produced by Apple factories, with a weak response from Apple. However, iPhones aren't the only ones adding to pollution. Many other tech companies also participate in similar activities. Organizations like Greenpeace have been finding hazardous parts and risks of iPhones since the first generation in 2007. While Apple has slightly improved the models over time, they remain largely consisting of many elements and minerals that must be safely disposed of. The question remains, what will the iPhone of tomorrow look like? With all the hoopla, maybe tomorrow's iPhone will hurt the environment less.